All right, you're welcome back, and let us look at, as we promised in the previous class, arithmetic progression. Another short form for arithmetic progression is AP. The examples that we just did, that was more of an arithmetic progression. So what is arithmetic progression? Arithmetic progression is a form of sequence. Let's put that onto writing. This is a form of sequence. This is a form of sequence in which each term is gotten by addition of a common difference. Yes, if we just did something like this, gotten by the addition of a common difference. So like what we just did, having the common difference of 10 and 20, which is 10. If you keep adding up, like this is 10, if you add up 10 to this, you're going to have the next one, which is 20, and then you add up 10 to read, you're going to have the next 10, which is 30, and you add up 10 to read, you're going to have the next 10, which is 40. So when you add up a common difference to a preceding number, that kind of sequence is what we call an arithmetic progression, an AP, an arithmetic progression, sequence to a common difference to the preceding one. So when you add it to the preceding one, yes, that is you having an arithmetic progression. Okay, so what we did in the previous video, the examples that we just did, was more of an arithmetic progression. And another name for arithmetic progression is what we could call the linear sequence. I call the linear sequence. The linear sequence is another name for arithmetic progression. And there are some examples. You can still take some examples of an arithmetic progression, and then we could have it like the one we had before. We could still have another like 12. After 12 we have 19. 19 we have 26. After 26 we have 33. If you observe this, what would be the common difference here? The common difference here is subtract 12 from 19. If you subtract this, that is 7. So the common difference here is 7. And if the common difference here is 7, meaning the common difference here will be 7 as well, it will be 7 as well. So if you add up 12 plus 7 is 19. If you add up 19 plus 7 is 26. If you add up 26 plus 7 is 33. That gives us the arithmetic progression, or what we would call the linear sequence. All right, so let's look at something that is called the nth term of an AP. Let's proceed. Okay, so let's look at the nth term of an AP. When we are talking about the nth term of an AP, we are talking about a rule. It's a rule or expression. Let's say is a rule or expression, that allows us to find the value of any term. The value of any term in an arithmetic progression. In an arithmetic progression. So when it helps us to do that in arithmetic progression directly directly from its position. So just think of n term as the formula that helps us to find any value, to find the value of any term in an arithmetic progression. We are going to look at the term together, how to have this term together. And now there is something that we need to know. Remember, we had our example of arithmetic progression. I want to use this last example that we wrote out, that is 12. After 12 we had 19. Let's use commas. After 19 we had 26. After 26 we had 83. Okay, so this is a sequence. If we want to know, okay, these are the position of the first term, the position of let's do this. These are the position of the first term, these are the position of the second term, position of the third term, and the position of the fourth term. It continues till the nth term. So in between these, you could be asked to find the 12th term. You can be asked to find the 12th term, and it will be so tiring. It will be so tiring for you to be adding up. Like, we know that the common difference here from what we saw, common difference here is 7, and to have term 4, to have the fourth term, we added. You just add the third term. You add it with 7. That is, the third term here is 26. 26 plus 7, and that gives us this 33. Great. Now, for us to have the fifth term, what do you think we are going to do? For us to have the fifth term, we are going to now add the common difference. That is 33 plus the common difference. Common difference is 7, and that will give us what? That will give us 40. So if we were to have the fifth term here, we are going to have here as 40. All right, you're going to have that 40, and you can proceed. So for you to have the 12th term is really going to take time. It's going to take time for you to be able to find out the 12th term or any particular term. That is where n term comes in. That is where this formula that we are going to derive comes in. That helps is this rule or expression that allows us to find the value of any term in an arithmetic progression, anywhere, any term at all. Okay, so let us establish some things. Okay, this first term here that we have, in this sequence, that happens to be a that happens to be an AP. We are coming to GP very soon. Okay, this first term here can be denoted with A, can be denoted with the letter A. All right, that can be denoted with the letter A. And of course, by now we know that the difference, like what we did here, the difference here was 1, the difference here was 10, the difference here was 7. And the common difference is denoted, can be denoted D, can be denoted with letter D. All right, let's use another color there. Can be denoted with letter D. All right, now if we want to pick this one here and start to create the series, or start to create the sequence, the values, start finding the values in each of these numbers, there is something that we are going to observe. Let's try to do it together. For example, this one, and that is term 1. That is term 1, and the value for term 1 is what? The value for term 1 is 1. Now, for us to have value of term 2, to have value of term 2, which we have as 2, how do we get to this 2? It is simple. How we have this 2 is just for us to add. We are going to add something to the first term. And what are we going to add to the first term? We are going to add the common difference. before we add the common difference, we will now know the number of terms that we need. And the first term here was 1, and this is the content, so you're going to have here as 2. And then we take away 1 from it, and then we multiply it with the common difference. I'm just going to go ahead straight up so that we can just have the formula for it. Now, to be able to solve this simple formula that we use to know the nth term. Now say that the nth term of an AP, that is when we have like this, is called nth term of an AP, is equal to the first term. So far you know the first term, and the first term will always be given the first term, and then we are going to add it up, that first term, to the difference, to the common difference. But before then, we need to know the position. We need to know the position of the term. So the number of term minus 1, then we multiply it with the common difference. This is always the formula that we use to find the nth term in an arithmetic progression. For instance, this term here that we have, this is term number what? 1, 2, 3. This is term number 3. If we did not know this as 21, we can solve for it using this our formula. We can solve for it. And how do we do that? We know the first term, right? The first term here is 7. So in the place of a, we are going to introduce 7 in the place of a. We're going to bring down our plus sign, and then the term that we are looking for is the third term. We are looking for the third term. So that will just be here, the third term minus 1, and the common difference here is 7. Common difference is 7. We just finish it up. And here, we still bring down this R7 here, bring down 7, and then we subtract this. 3 minus 1 is 2. So here is 2, and then 7, we multiply this 2. So here will now become 7 plus, and what would we have here? What we have here is 14. And then 7 plus 14 will give us what? Will give us 21, and we add here 21. All right, so if you don't know the term and you have been asked to find the term, you simply use this formula. And when you use this formula, you will have the correct answer. As we take some examples, we will get more comfortable with this. Okay, see ya in the next class. Bye-bye.